In this lesson we're going to look at some more questions on how to pass the unit assessment for relationships. So let's look at question 7. The equation of the quadratic function whose graph is shown below is the form y equals x plus a squared plus b, where a and b are integers. Write down the values of a and b. Now, what we have to understand here is the bracket shifts the quadratic sideways. The value of a will shift it sideways, and the value of b shifts the quadratic up and down. From the origin, from this point here, it moves it. Now, in order to understand how far it's been moved, you have to look at the turning point in the graph. Now, the turning point in the graph is this bit right at the bottom. That's your turning point. In this case, it's 2, 2, 2 along and 2 up. Being careful to note here, this scale's going up 2, 4, 6, 8, 10, 12 and so on. Now, because the graph has been shifted forwards to 2, that means the x value here is 2. But I'm not looking for the x value, I'm looking for the a value. Now, because the x value is 2, the a value needs to make this bracket 0. And the reason it needs to make this bracket 0 is because the minimum turning point happens at the lowest point. And the lowest point of a squared bracket is 0. You can't get a negative number squared to get lower than 0, because when you square a negative number, it always becomes positive. So again, because the x value is 2, to make the bracket equal to 0, the lowest point, a needs to be negative 2. So that's your first kind of point to note. A is, where have I put it? A is negative 2, I'll just write it. So we've got a is negative 2. Now, the second value, the b value, is just straightforward. It's how far up or down it's moved. In this case, it's moved up 2, so that means b is 2. If it moved up to 3, b would be 3, and if it moved up to 4, b would be 4. And the same if it went down to negative 1 down here, b would be negative 1. I'll just see if I can find where I wrote that out. Okay, I've wrote it in the equation. You can do that as well, but a is minus 2 and b is 2. Right, question 8, one of the hardest questions there. There's quite a lot of working to this. Sketch the graph on plain paper of this y equals x plus 4 times x minus 2. Mark clearly where the graph crosses the x axis and the y axis, the axes, and state the coordinates of the turning point. Now, the first thing to note here is we can work out the roots. That's where it crosses the the x axis. So the roots are where that bracket equals 0 and that bracket equals 0. In this case, the roots would be x equals negative 4 and x equals 2. So straight away you can see that and then put that in as your roots. That's because it cuts the x-axis when y is 0. So to make y 0, either that bracket needs to be 0 or so does that one. Okay, so now I've got my roots where it cuts the x-axis. I can work out where the turning point is. It's halfway between these two things, from symmetry of the quadratic. So if you find the halfway point of 2 minus 4, add the two numbers together and half them, and that comes to minus 1. So we know the turning point's at minus 1, but where's the y value? Well, if you put it back up in here, put the negative 1 there, and the negative 1 there, it will tell you the y value at that point. So that's what this next bit's going to look like. So I'm subbing in minus 1 to there. So that looks like this, minus 1 add 4, multiplied because the brackets are next to each other, minus 1 take away 2. Now, negative 1 plus 4 is the same as 4 take away 1, that's 3. And negative 1 take away 2 is further into the negatives, so that's negative 3. So that works out to be minus 9. So you get a minimum turning point at negative 1, negative 9. Why is it a minimum? Because if you multiplied out this bracket, you would get an x squared term that would have a plus in front of it, and that creates a minimum. If it had a negative in front of it, it would create a maximum. Right, the last thing you need to do is you need to find out where this graph cuts the y-axis, and it cuts the y-axis when x is 0. So similar to up here, when you knew x was minus 1, you subbed it in. If you know x is 0, you sub it in. So that's going to look like that, 0 plus 4 times 0 minus 2. Now 0 plus 4 is easy enough, that's just 4, and 0 minus 2 is negative 2. So if you times that out, you get minus 8. So you've got a y-intercept of 0, minus 8. So these two bits here are very, very similar, the sub and in parts. And that is just making the bracket equal to 0. Sketch it out, should look like this, and job done. Make sure you mark in all the points that you've worked out here. Okay, question 9. A parabola has equation y equals x plus 2 squared minus 3. Write down the equation of the axis of symmetry. So we need to know that this again moves the graph sideways and this moves it up and down. So if I was trying to work out what the graph would look like, I would think, well, it's been shifted backwards 2 places, as we talked about earlier, and it's down 3 places. That's where the turning point would be. It would be backwards 2 because it's the opposite of the plus 2, and then down 3. Now because it's moved backwards 2 places, that's where the axis of symmetry is at. So the axis of symmetry is just minus 2. I don't know if I've written it here at all. Oh, here it is. X is minus 2. Now the turning point, well, that's at minus 2, minus 3. So minimum turning point at minus 2, minus 3. Why is it a minimum? Again, because if you multiplied that bracket out, you get a plus x squared, which creates a minimum. Only a negative x squared creates a maximum.